So as we have looked at the definition of matrix now, we will move towards the types of matrix, right? So, so first type is, which is very important type, is unit matrix, right? And what is unit matrix? If you recall from mathematics, so from very basics, so you know that the number one is a unit. So if anyone is multiplying with unit numbers, so it is going to give you same result. So there is similarly we have a matrix or unique matrix or identity matrix, which are also known as the identity matrix. Identity matrix, right? So um, identity matrix is something like this: 0, 1, 0, 0, 0. So this is the identity matrix. This is the identity matrix. Identity matrix. And one important thing I want to tell you about this is the principal diagonals, right? So the only elements are available here. These elements are available here, and these are the ones, right? So if any matrix that has the only element, suppose there is a 0 0 0 b 0 0 0 c, and such kind of matrix is actually known as the diagonal matrix. Yeah, it is very important to know about it. Diagonal matrix. So because there would be only diagonal elements, and it could be anything, and you'll be using this to when you'll be forming some characteristic equations and solving the equations, linear equations, right? Homogeneous or heterogeneous equations. So ABC, as you can see it here, this would be any element. So if these elements are 1, 1, 1, then it's going to be identity matrix. And if you multiply this matrix with any matrix, it's going to give you the same result. And we'll be using this in multiplication and finding the inverse. Second very important matrix is null matrix. Null matrix. Right? And the best thing about null matrix is as you can see that the null value is going to be null, right? So 0, 0, 0, 0, 0, 0, 0, 0. So this is the null matrix, right? And the characteristic of null matrix is if you add null matrix with any matrix, it will going to give you the same result. There will be no different. There will be no changing. And we'll be using these two matrices. We have to remember this, right? So null matrix and this identity matrix. And then we have kind of row matrix, right? So row and column matrix. Column matrix. So if any matrix has only one row, which is going to be row matrix, and if a matrix has the many number of columns, sorry, one number of column and many number of rows, it's going to be, so it would be something like 1 into n, right? And so m into n, so 1. So you can see it here, the one row and n columns, m number of rows, one column. An example, if you have to look at the examples, you will see that something like this. Okay, now you've seen the row matrix and column matrix, and the any kind of matrix is going to be submatrix. To define submatrix, you could go at set theory, right? So what you have seen there is suppose there is a set, right? A 1, 2, 3, 4, right? So this is a set. And if you have to find the submatrix subset of this value, suppose you have taken one value, right? So this is going to be subset, or you could take more values here, one, two. This is also going to be subset of A. So similarly, we have some matrix. Suppose there is a matrix, and we have taken some value from there, and this will going to be some matrix of a matrix. Suppose next example is a matrix here: 3, 4, 5, 6, 7, 8. So this is the matrix, right? And we have taken another matrix here, and this will be from this, right? So just ignore the first row. So we will get 4, 5, 7, m, and this is the submatrix. B the submatrix of A, you could say. Then we have the another kind of matrix which is principal submatrix, something known as principal submatrix. And what is principal submatrix? So principal submatrix is, you can think of it this way. So any square matrix, right? So suppose there is a square matrix 4, 5, 6, 2, 2, 1, 8, and 10. Right? So suppose this is a 3 into 3 matrix, right? And if you're going to remove one row or one column, right? So you're going to get another square matrix. So this is A, and you have removed the one row and one column, so you get the 2, 1, 9, 10. Right? So this is the principal submatrix. It means that you'll be removing the same number of rows and columns, right? So, and the best thing about it is if you form some matrix is also going to be a square matrix, right? So if you look at it 3 into 3, it's going to be 2 into 2. So it is some kind of a square matrix. And then we have another kind of matrix. So transpose of a matrix. So transpose matrix. This is also a very used matrix, right? So what is transpose? Suppose you have a matrix, right? Here, A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you have to find the transpose of this matrix A dash. So generally represented by A dash, or sometimes people represent it with this way, PA, which means the transpose of this matrix. So what you could have to do is you have to just reverse the order, which means that you could say um, just make the row as column and column as row. Okay, just take one thing here. Make the rows and columns as columns. So 1, 4, 7, 5, 2, 5, 8, 3, 6, 9. Right? So this is the transpose of A. So what you have done is I just taken this row and just making it like this, right? So then taken this other row and making it like this, row like this. So that's how we form the transpose of the matrix. Then we have the symmetric matrix, right? Symmetric. Now these three matrices are enough that I've told you, right? So here I told you two matrices. Okay. Okay, so I was telling you the important matrix matrices are the identity matrix, right? Which is identity matrix. Okay. identity matrix, and null matrix, submatrix, and principal submatrix. And this one matrix is symmetric matrix, right? Symmetric matrix. So what is symmetric matrix? Symmetric matrix is basically if you transpose any matrix and it will going to give you the same matrix, right? This way. Or so some matrices are known as the symmetric matrices. Suppose you have something like this, 1, 2, 2, 1, right? So this is A. So if you're going to find the transpose of this matrix, right, you will get something like this, 1, 2, and will be something like 2, 1. So this matrix is actually a symmetric matrix, right? And there are many other schizometric matrix, symmetric matrix, and conjugate matrix. And we'll look in these matrices when we're going to use those matrices, right? So the basic thing is, basic idea is, suppose these matrices are the square matrices, right? So you must have to remember this. Um, we will perform all the operation over square matrices, not any other matrices. I know this one. Okay, yes. So I told you the third matrix. Okay, here we have the null matrix. So null matrix is also kind of a square matrix, right? Where we using, you can take it any kind of rectangular matrix that you use for it. And then we have the identity matrix, and this is all going to be the square matrix, right? So this is kind of the square matrix. And principal sum matrix is generally is another kind of a square matrix. Some matrix may or may not be square matrix. Okay, so that's enough, right? So we're looking more about this in detail when we solve the problems. Thanks for watching.